right, guys. Actually, super simple today. We're going to talk about the surface area of a sphere. And this is one of those things that's very, very complicated to explain, but the equation's really easy to use. So it's one of those odd things in math, kind of that we can do before we even really kind of understand what it means. So I can't really explain to you guys why the surface area of a sphere is what it is. Pretty straightly put, the surface area of a sphere is, if you surface area of a sphere is really easy, is equal to 4 pi times the radius squared. So if we think of a sphere, right, and it's going to be hard for me to draw this, but I'll do my best. If we took a sphere, right, and we kind of, I'll do my best. It's very hard to do. But if we kind of drew this as a sphere, right, and it's now three-dimensional, right? Right, and we still have a radius, right? Spheres still have a radius, right? If I have this kind of circle in the middle, right, the area of that circle, pi times radius squared, if I cut this circle out and I kind of glued it around the surface of a sphere, it would fit exactly 4 times, which is just, it's one of those, odd feats of math, and it shows you kind of like how perfectly some of these things work. Surface area of a sphere is really important in nature. It's typically why you have cells that are spherical, but why you also have planets that are spherical, and then also why cells don't get bigger and bigger and bigger because there's almost like a diminishing kind of return. And we'll talk all about that in class on Monday because it's kind of complicated. It's going to take me a little bit of time to explain to you guys. So I don't want to, I know if I make the videos more than like 8 minutes, nobody watches them. So real straightforward, if I told you, hey, the radius of the sphere is, I don't know, 3 inches, then really all you have to do to find the surface area is I can say, well, it's 4 times pi times 3 squared. And 3 squared is 9. And 4 times 9 is 36. So 36 pi inches squared. And again, if you wanted to evaluate that, you can go ahead and break out your calculator and say, well, 36 times pi, right? And it would be that, 113.09 square inches. Or like IXL is asking you to do, 36 times 3.14. So it's pretty straightforward. There's not really a whole lot more to it than that. Again, if you wanted to kind of conceptualize how you would find the surface area of a sphere, if you had a sphere, right? And again, think about it if you had a piece of tape, right? Like a piece of tape and you were kind of just winding it around, right? You kind of started at one side, you just kind of kept going, right? And wrapping it. Well, you could find the area of that very thin rectangle, right? And the idea is that you use something like calculus to make that kind of strip infinitely thin, right? You're allowed to do that in calculus. And if you kind of added all those up as they wrapped around and around, think like a tennis ball, if you just wrapped a piece of string around it and around it and around it and around it, eventually you'd cover the whole thing. And that's really how you do it in calculus. But I really can't explain that to you guys because you guys haven't kind of reached that point in math. But I will explain to you guys why it is important. I'll give you guys a quick, easy example, and that is one of the new fads, and that's spherical pieces of ice for drinks. And part of the idea is that if you had the same volume, right, if you had the same amount of frozen water, that there'd be less surface area, there'd be less exposed to your beverage in here, which means that the ice would actually melt slower than a standard ice cube. So what it does is for the same amount of volume, it minimizes the surface area. And if you look down here, like many things we see, as we add more and more sides, we see that the amount of surface area in comparison gets lower and lower and lower and lower. So that's why it is kind of important in nature, because you have the same amount of volume with less surface area. Less of the surface is exposed compared to the same amount of volume. So this and gravity tend to make a lot of things in the universe very spherical, because it's a much more efficient way of doing things. But we'll talk about that kind of in depth on Monday. So again, like I said, you're just going to take it, you're going to plug the numbers into the equation, and you guys should be able to do it from there. So I'll talk to you guys tomorrow.